Hello again, Tom from Every Step Calculus, EveryStepPhysics.com. This is more puzzles from calculus. This is a chain rule dealing with partial derivatives. Probably have this in calculus too. I want to do a couple of movies of this subject to help you in case you need it. Index 8 to get to my menu. You'll notice that it's a chain rule and they give you this z equals x cubed plus x times y squared, and then they give you these u, v, and w amounts, plus they give you the actual u, v, and w amounts here too. So let's see how my programs work on this. We're going to scroll to chain rule, because that's the problem. I can't imagine this being on a test, either way too difficult for that, but never know about these professors, how they do things. Now we're going to scroll down to what they're asking for: partial of z with partial of u, partial of z, partial of v, partial of z, partial of w. I'm going to scroll down here to see if we can't find that. Here's az, aw, az, av, az, aw. There it is. This is u, I guess. Very small to see. One thing to note on these, excuse me, to add the letters of these type of things here, u times v cubed and everything, you're going to have to press alpha twice to add the letters. Also, a here is the only way I can figure out to do the partial sign for the partial terms. So we're going to enter the functions here. Now I've already entered them to save time and effort here. X cubed, y squared, here it is right here. X times y squared, sorry. Say it's okay, you can change it if you made a mistake in my programs. I've always consider that when I'm programming for you folks out here trying to pass calculus. And we're going to enter the x with the u, v, w. That would be this section here, okay? And we're going to enter the y section just for examples here. You'd press alpha to enter here, and the y is u plus v times e to the w. So you're going to have to press alpha twice. Y equals, that's twice. We're going to put the u in here. U is here. The letters above the numbers are the alphabet which you're trying to access here. And we're going to go plus. And then V. Where's V? Let me see on my calculator here. V is the O. Whoops. Press alpha again. There's V. And of course times, and then we have to press the yellow one here to get to the E to the W. I have to press alpha again to get the W. Sorry for this. Which is the period sign here. Close off the parentheses. and then we're entering the other ones. I've already entered them here now, so I'm going to continue on. I just wanted to show you how you enter the letters on the calculator, okay? Say it's okay, and we're going to do each one of these. AZ, AU, partial of Z with the partial of U. That's the first one. Here's the formula. Write that on the paper. You've already got 2 points, 3 points, just for writing the formula. The partial of Z, which is this right here, with respect to X, is this right here. You can do partials, can't you? Sure. And here's the partial of Z with respect to Y, which is this right here. Partial of Z with respect to U is V cubed. And partial of Y with respect to U is 1. We put them together here just like the formula. And now when we got U equals 2 and V equals 2 and W equals 0, we add that into the what X equals here, which is right here. Turns out to be 16. Notice you're going to put parentheses around these where I'm substituting X into or Y into the function. I have to use quotation marks because that's all the program allows me to do. But you're going to remember that and put parentheses around these where you're substituting, okay? So you look like a real mathematician. And we do that for Y. It turns out to be 4, 16 and 4. Now we substitute that into the formula, you know, where we've entered these functions for the formula. These are the partials of these. And it turns out to be 6272. And the Y, partial of Z with respect to Y, and Y over W, 128. We add them together to get 6400, okay? Going to go back to number 2, AZ, do the same thing. I'll do it quickly here for you. Put them together here. Again, we substitute 2, 2 and 0. Turns out to be 16 and 4 again. Turns out to be 18, 8, 16. And 128 turns out to be 18, 9, 44. Now, I'm still not sure what this number represents. It's supposed to represent the derivative of the function. And the derivative of a function is really the slope of a line, okay? So this is the slope of a line. There's a 1 under here. So you notice how steep this is. You're going to go up 18,944 increments on the y-axis, and then 1 over on the x-axis, and draw a line from that point down through the origin of the graph. That's the slope that we're figuring out here, okay? We've got here. Total nonsense. I mean, it's useless. All calculus is useless for anything practical. So now we go back and we'll do number 3. Okay? And we write all this on your paper. Substitute 16 and 4 again. Turns out to be 784. Turns out to be 256. Pretty neat, huh? EveryStepCalculus.com. Go to my site, buy my programs, and pass calculus. Also, think about subscribing so you can see other videos of mine, okay? I have almost 600 videos of calculus and physics for you to enjoy and pass your classes. Hey, have a good one.